Hi, welcome everyone to today's LinkedIn Live session hosted by Everest Group. I'm Jillian Walker, and I'll be moderating this session on the next top 10 game-changing technologies in AI. While we wait for everyone to join, why don't those of you who are already in the audience tell us where you're tuning in from? We'd love to hear where you all are. Okay, so over the next 45 minutes, we're going to explore how these technologies, these top 10 game-changing AI technologies, how they are shaping the road to artificial general intelligence and what that might mean for enterprises looking to build more future-ready strategies. So with me today, I have three of our analysts, Research Director Isaac Premsing, Research Director Kasturi Jagadisan, and Senior Analyst Himanshu Matra. And all were significant contributors to this research. So really happy to hear their thoughts on this subject matter. Before we get going, I would like our audience to know that we have made available a copy of our article, Demystifying AI, which is available for download. So please feel free to scan the QR code on your screen to get a copy of that article. So I'm going to turn first to Isaac here and ask him a quick question around what do we mean by game changing? What really qualifies as a game changing technology in this analysis? And what signals or metrics are we weighing most heavily in order to make that judgment?
Yeah, sure. Thanks for having me on this LinkedIn Live, and thanks to everyone for joining in. So happy to be here. So here, for us, game changing is a technology that is disruptive in general, but by disruptive we mean technologies that can potentially displace existing technologies. And in specific to AI, we're looking at technologies that can advance AI's capabilities in comparison to what we see today over the next 4 to 6 years. So in this particular study, while selecting these technologies, we really had to comb through a lot of research literature. And there are minute variances between what one technology means versus the other, considering that AI is sort of all-encompassing, and we have multiple architecture and different training methods, and model definitions vary from company to company. So we looked at setting apart the technologies that are more strategically consequential from the interesting science projects, if you may look at it that way, right? So we had to look at the more sort of effective filters that we can use to evaluate these technologies. And this is a filter that we've successfully used for multiple technology domains. And we've sort of slightly modified it to accommodate the variances in AI's context as well. So factors like magnitude of intellectual property filing, the degree of funding, and the potential impact to the market. So the markets in which AI has potential applications and the implications to what the market dynamics would look like. And we also look at the mega forces. So mega forces is a major part of what we do AST within Everest Group. And we look at how these technologies align with what the mega forces are and how they can significantly shift the needle in terms of where we're all headed, right? And then the regional relevance, how do we see this technology sort of becoming more pervasive, and the degree of diffusion that we see across regions, and the confidence of the team itself. So in order to arrive at these technologies, we kind of get together, we have internal working sessions and workshops, and we also validate our own convictions by kind of using some of our external experts as a sounding board. So, and also we look at signals, right? So signals are early evidences of technologies that we see having a significant recognizable impact. And we weighted those signals in terms of the likelihood that they have across enterprises, in terms of how they drive a switch towards this new technology, and also how they can materially displace what we are using today. And so this is how we've kind of arrived at these technologies, and really game changing in our context equals evidence backed research and technologies that are adoption ready, and also in AI's context advancing towards AGI in some form or fashion that we will see in the long term. Yeah.
Yeah, and I mean, I know we've been throwing around this term AGI, but I think it is worth us taking a step back and even defining that term from Everest Group's perspective. So I'm wondering how are we really thinking about AGI, what that means? And I know as part of this research, we built, I think, a pretty comprehensive roadmap that illustrates all of the various technologies and how they're coming together to advance this kind of goal of artificial general intelligence. Maybe we can go ahead and show that roadmap here. I'd like you to talk a little bit, not only about what we mean when we say AGI, but about this roadmap, what it's illustrating, and what this map really represents, how it is showing this potential sea change from today's AI capabilities to this kind of more human level or superhuman level intelligence.
Yeah, I think this is an important thing to do whenever we talk about AGI or ASI, and we've grounded our research on certain simple facts and truths, and understanding that AGI is sort of a really hypothetical state in the future where it is a system that thinks, learns, and adapts like humans across any domain, right? In a sense, it's a general form of human that supersedes human capabilities across any domain. So, so in our view, the road to AGI is sort of an evolutionary journey that's already unfolding. So that's why we put together this sort of a visual. We wanted to, ground ourselves in some foundation and try to build up from there. And we've tried to position our top 10 game-changing technologies on this sort of a maturity curve that you see here. So we see AGI as an outcome of cumulative advances in model architecture, computer efficiency, and responsible governance in AI, rather than it's just not a technological leap or a sort of a singularity moment, if you may, right? So it's an evolutionary pathway, and we frame this evolution through AGI maturity levels on the left of the chart that you see here. We define 4 sequential levels: embryonic, human level, superhuman, and ultimate AGI. So each of these levels are characterized by measurable gains, and we've defined the characteristics of each level across those AGI enablers that you see there. So we wanted to look at what AGI will need as an enabler to be this superhuman general intelligence, right? So we sort of classified the 6 AI enablers: learning, memory, reasoning, social cognition, safety, and infrastructure. So, and we've looked at technologies that are mapped to each of these enablers with consequential improvements that lead to the next level of AGI, right? So, and we see that the gains are across reasoning, specific domain specific reasoning, continuous learning, and alignment with human intent, right? So for a particular task, what's the human intent? What are we trying to achieve? And how do we go through the process of reasoning and learning and then aligning with those objectives, right? So in our study, we emphasize that the enterprises are already experiencing some level of embryonic AGI in some shape or form, as we see the adoption of multimodal foundational models, vertical LLMs, explainable reasoning systems, sort of task level, and also self-learning algorithms limited to tasks. So while evaluating enterprise AI capability building projects, we believe that this sort of a framework helps enterprises to design project purposes that grow capability with responsibility. So there are sort of 2 trajectories that overlap in this maturity curve. One is on the capability growth, and the other one is on the responsibility growth, right? So by this, we mean that learning, memory, and reasoning advance in parallel, with explainability, safety, and governance, right? So and they have to keep in pace in tandem as both mature together. So the value realization really depends on how much operating controls and cost curves are we able to achieve in terms of deployments and scale up while building this capability and responsibility.
Yeah, and I really appreciate the maturity levels that you've mapped out here. I'm wondering if you can go just a little bit deeper into those and explain those a little bit more, and maybe tell us where today's frontier models would fit in this overall scheme.
Yeah, I think this is really important, right? So we've defined 4 levels, and there are different variations of these levels that we find. But for our research, how we want to look at it is, this is a ladder, and each rung has different characteristics, and we would like to understand what characteristics can be enabled by what technology, and how carefully we need to govern those capabilities as we progress. So I'll take you through these 4 levels, and along the way, I'll point out some of the responsibilities that might rise with capability as well. So level 1 is like hiring a talented generalist, right? But the generalist still needs tools, and the generalist is able to perform certain tasks. It's quite fast, versatile, but it still lacks the ability to learn on the job without guidance, right? So at this level, trust is a function of how we define the process of enabling trust. So we keep the human in the loop for meaningful decisions. We ask for sources. We use basic policy prompts and red teaming, and we log everything, right? So as we climb to the next level, we begin to see some sort of a pairing, more capability with stronger accountability, right? So level 2 becomes a sort of a specialist teammate. So at least one mixture of expert in the model, and we probably have a couple of them, and you can assign outcomes that you want the mixture of expert or the model to perform while performing complex tasks. So the model remembers how the business works, for example, in business context, and it also improves during use, and it's able to explain the logical reasoning behind some of the tasks and choices that were made. So it should automatically be able to follow certain actions in terms of disclosing the reasoning behind the tasks that were performed, and also escalate the edge cases for further human review. So this is sort of a specialist teammate. So the level 3 is where we start achieving some sort of a bounded autonomy, where multiple agentic systems, multiple MOEs, are able to plan, simulate, and optimize business operational outcomes across functions. So now at an enterprise level, each function has multiple experts and as in agents who are able to perform certain actions across functions. So supply chain, pricing, workforce management, all of those included. And at this level, because the stakes are much higher and we allow the agents to take action on mission critical tasks, we need to enforce certain safeguards. And the safeguards should also be defined in a way where we have certain rollbacks, but also reach a place where we eventually may even incorporate a kill switch for some of the tasks that are being designed to operate. And now continuous risk monitoring and proof carrying decisions becomes a critical requirement, right? So level 4 is what we define as systems of systems. So here we move from mixture of experts to mixture of systems with open-ended capability. By this, what we mean is the system is able to design new processes, invent new methods to carry out certain tasks, and anticipate long-term consequences as well. So, which means that there is a full autonomy to the system, and there is ability to perform tasks based on self-learning and self-improvement at the model level as well. So, and these are systems that can be at an enterprise level, managing an ecosystem of factories. Sort of in a manufacturing context, we can look at the factory optimum that can be achieved by these systems of systems, which will optimize for all zero outcomes in the manufacturing setup, and it can be across geo-distributed assets. So in this context, the execution scope and decision rights must be tightly defined. So this is where there are a lot more unknowns on what we can do in terms of increasing the level of accountability for the actions taken by the systems. So as much as we know the technology is sort of progressing towards it, it's still an hypothetical level where there are so many unknowns and we don't know what we don't know, right? So that's the level that we see the ultimate AGI being. So seen together, I mean, the levels trace from a simple arc, starting from tool assisted generalists to specialist collaborators to agentic teams, and finally agentic systems of systems. And when we look at the frontier models that we see, all of them, most of them fit within level one embryonic AGI. So at the upper end, so which means that, for instance, multimodal models show broad task coverage and tool use, but they don't yet learn reliably inline. So inline learning is still a gap, meaning learning from new experience or explaining decisions to audit grade for certain critical applications, and this is not yet by default, right? So a few examples include the OpenAI GPT-4V with strong context-efficient reasoning, tool use and rack support as well. And we also see some of those domain-specific vertical models like MedPalm 2 in healthcare, Bloomberg GPT, Red Genius in the legal side. So all of these models are getting tuned on domain-specific ontologies and policy controls that are aligned with the actions that they're sort of designed to perform. And these are some good examples that we see in level one embryonic AGI. Yeah.
Yeah, great, great. I mean, thank you for doing this map, which really does illustrate how it is a confluence of all of these technologies that will have to come together to achieve this AGI state. And I think we really could spend a whole hour just talking about this one illustration, but I do want to switch gears a little bit and talk more specifically about the top 10 technologies that we highlight in this map that we want to really bring forward today. And for that, I'm going to turn to Himanshu. Himanshu, I want to start with you. I want to ask a question around the technologies that are giving AI maybe more of a richer perception and contextual understanding, where we think of machines really beginning to kind of see and sense like humans. So these kind of, I think we're calling multisensory world models, right, that integrate vision and sound and touch. Why are those so pivotal right now? And which use cases are you seeing that are signaling readiness for that technology?
I think that's an important place to start, Jillian, because perception is what truly sets the next generation of AI apart. In my view, multisensory world models are becoming one of the most exciting breakthroughs in AI because they push machines beyond simply seeing or hearing as they enable AI actually understand and predict how the world works. So up until now, most AI models have been good at perception, which means they can process text, images, or sound separately, but they don't really connect these senses or grasp how things interact. But a world model changes all that. It uses all these sensory inputs together, uh, including the vision, touch, motion, to build an internal simulation of reality. In other words, it allows AI to not just see what's happening, but also anticipate what might happen next. Uh, think of it as giving AI a kind of intuition. It can predict the path of moving object, or it can understand how forces interact, or even simulate possible outcomes before even acting. So this is what makes world models so powerful. They move AI from perception to reasoning, and we are already seeing this come to life. For example, DeepMind's Gato and RoboCat. They are some of the early examples. What they do is they integrate visual, tactile, and motion-based learning, so robots can perform multiple tasks and adapt without retraining. There are also several other examples like Meta's Project Aria and Ego 4D. What they are doing is they are collecting massive amounts of first person video, sound, and motion data to teach AI how humans perceive and move through the world. So When it comes to enterprises, the potential is enormous with this kind of technology. So, for example, in manufacturing, these world models can simulate changes to production lines before even implementing them. Or let's say in healthcare, they can support a robotic surgery or a diagnostic imaging by modeling complex patient data. And when you see in automotive, there are a handful of companies like Huawei is there, Momenta Global is there, Wabi. So these companies have developed good world models. They are improving how self-driving systems interpret and predict motion in real time. So, if I have to tell the audience in simple terms, multi-sensory world models give AI a mental model of a world, a way to connect perception with prediction, and it's where AI stops just processing data and starts truly understanding the context and setting the stage for systems, and that can reason, plan, and act intelligently in real world.
Great. So another interesting technology that comes to the forefront in our work is liquid neural networks. And we describe those as adaptive, efficient, interpretable. What breakthroughs do you see that make them different from standard neural nets?
So liquid neural networks or LLNs, they mark a big shift in how AI learns and reacts to change. So if we think about traditional neural networks, they are like students who study hard for one exam, and once they have learned the material, they can't adapt to new questions without retraining. But liquid neural networks, on the other hand, they can keep learning while they operate. So they are designed to be adaptive, meaning they adjust to new data or conditions in real time instead of waiting for a complete retrain. So what makes them different is their underlying structure. So standard neural networks, they rely on fixed layers and static weights. Once trained, these don't change. But in liquid neural networks, the connections between neurons evolve continuously using some mathematical equations that describe change over time. So this allows them to respond instantly when something unexpected happens. For example, if let's say lighting conditions change for a vision model, or let's say noise increases in a sensor, the model, it will automatically rebalance itself to maintain the accuracy. The breakthroughs are already visible in the real world examples. There is one example with which is I think MIT is doing that. So researchers at MIT, they have built drone navigation systems using liquid neural networks that could adapt mid-flight to the wind turbulence. And it can do that hundreds of times faster than the transformer-based models. Uh, Even there is another example wherein NASA's Jet Propulsion Lab, they are testing these liquid neural networks for autonomous spacecraft, where systems need to make decisions without waiting for instructions from the Earth, because it takes a lot of time. So these experiments, they show that AI can now react almost like a living system, not like a programmed one. Uh, then another key advantage with these liquid neural systems is its efficiency, because liquid neural networks deliver strong performance using far fewer parameters than today's large language or large transformer models, which means they need less compute power and energy, and that makes them perfect for small on-device deployments like robots or sensors or wearables or industrial controllers. So for enterprises, so this adaptability and efficiency are really game changers. It means that AI that can run faster, uh, which cost less, and that can even handle unpredictable real world environments with minimal downtime. So all in all, in short, I would say that liquid neural networks brings us closer to true responsive intelligence. They are AI that learns and adjusts as naturally as the world around it changes.
Great. And so just continuing this with this theme of perception and understanding, maybe we should talk a little bit about cognitive digital twins. So we know of digital twins, right? But with cognitive, now we're moving from monitoring to reasoning and prediction capabilities, more sophisticated prediction capabilities. Why don't you tell me a little bit more about that particular technology and what industries are furthest along, and what are the barriers that are still really remaining for that technology to really prove its ROI?
Great. This is again interesting technology. So these cognitive digital twins, I believe they are a huge step forward in how AI interacts with the physical world. In simple words, I would say a digital twin is a virtual copy of something real, like a factory line, or a power grid, or even an aircraft engine. But when you make that twin cognitive, it stops just being a mirror. It can now reason, predict, and even make decisions based on the real-time data. So industries like manufacturing, energy, aviation, they are making significant advancements in this digital twin area. So because they deal with complex high-value systems where even small improvements, they mean massive savings for them. So for example, Siemens, it uses cognitive twins in its accelerator platform. So machines can detect performance drifts and they can adjust automatically. There is again G Digital, which uses these cognitive digital twins to predict the turbine behavior and balance the grid loads. There are again examples in the aviation sector wherein Airbus is using them for numerous simulations to save time, cost, and risk. So what's exciting in that these twins, they are moving beyond dashboard. They are now getting intelligent. They are now being the intelligent partners that forecast problems or simulate fixes and suggest the next best steps by learning from each cycle of operation. Of course, there are still barriers in this technology, like data integration is one of the critical ones, because data integration across different vendors is tough. And again, the cost of building the high fidelity twins is pretty high. On top of that, governance is becoming crucial as these systems start to make semi-autonomous decisions. But I think the direction is clear, as far as I know, as because AI reasoning and edge computing, as they mature, we will see cognitive digital twins scale from pilot productions or pilot projects to full-scale operations. They are becoming the intelligent backbone of modern infrastructure. I think they are systems that don't just monitor the physical world, but actively they help it run better.
So if I can just ask one last question, maybe tying together these three technologies, what do you see as the common element that really brings them together in terms of this roadmap towards AGI? And do you see these as kind of near-term enablers, or are they more long-term bets? How would you characterize them?
Yes, of course, they are enablers in the near term. But what really ties these perceptual technologies together is that they are all teaching AI to move beyond pattern recognition and start developing contextual understanding. So they are helping machines not just to see or process the data, but to interpret what's happening around them, reason about it, and act accordingly, much closer to how humans perceive the world. Yes, each of these technologies, they play a specific role. So, for example, multisensory world models, they give AI richer perception by combining vision, sound, and touch into one unified understanding of reality. Liquid neural networks, they bring adaptability. They continuously learn and adjust to new situations instead of freezing after training. Cognitive digital twins, as we saw, they connect perception to action, they simulate, predict, and optimize real world systems automatically. But the common goal is what we call situational intelligence, systems that can sense, understand, and respond to contexts in real time. And importantly, these aren't distant or future ideas, they are near term enablers, as I said earlier. and they are already proving their worth. We are seeing multisensory robots in manufacturing, adaptive models in logistics, cognitive digital twins in energy, aviation, and multiple sectors. So while they lay the groundwork for AGI in the long run, their value I see is immediate today, helping enterprises build AI that's not only smarter but truly aware of the world it operates in.
Great, thank you, Manchu. So I want to switch gears just a little bit. We were talking about perception. Now we do highlight technologies that are maybe a little bit more aligned with the decision-making elements of artificial intelligence and how we can build trust in the decisions that AI is making. I'm going to pull in Castari here to maybe answer a few questions around that theme. So one technology area, I guess, that we can talk a little bit about in relationship to this is vertical LLMs. And they are really gaining traction, particularly in highly regulated sectors. And I think this has a lot to do with their decision-making capability and the trust that they build up. What do you think it is that makes them essential infrastructure, especially for these kind of industries that require very high trust in decision-making?
Sure, thanks there, Jillian. It's a very interesting question. So, what actually makes vertical LLMs important is the aspect of reliability, accuracy, and accountability it adds to the artificial intelligence platforms. So, we can generally think of a regular AI model like ChatGPT to be a more generalist because it knows a bit about everything. And it's very great when we ask some questions every day, but they're not actually experts in terms of the rules or the language for specific applications that we're talking about, like healthcare, finance, or law. So, what a vertical LLM does is it is more like a specialist. It is trained on the information that is very unique to one industry. For example, we can take clinical research papers, legal cases, or financial reports. And all of this actually requires the ability to understand as to what sort of conclusion we are coming into. And we can take a very simple example. Let's imagine we are asking a doctor versus searching on Google about a medical symptom. So, what we can think about, most of us are using ChatGPT, and this is going to be more like a Google. It can give you more broader information, which may be accurate or not. But when we take a very healthcare focused model like Google Med Palm 2, it's like asking an actual doctor, which means it actually relies on verified medical data, and it also gives answers that follow clinical standards. So you can actually see the difference. So where we see as a specialist versus a generalist. So ChatGPT is more like a generalist, and we are talking about vertical LLMs as a more of a specialist. And we can apply the same example to a concept of Bloomberg GPT for financial applications, which is trained on years of market and regulatory data. And this can actually help smart and compliant decisions to be made for specific examples. What we also see is as industries get to face more stricter AI regulations, and companies actually need systems that can rely on trust and audit. This is where we see the difference of vertical LLMs being or creating a sort of a differentiation. As they combine intelligence with governance, this can actually turn AI from a helpful assistant to more of a dependable digital expert that not only knows what it is saying, but it also understands what it is allowed and expected to say. So this is where we see the entire differentiation of vertical LLMs playing an important role in creating trust within a specific platform, and especially in very high trust industries like medical and so on.
Yeah, and when we think about trust, we always think about it in terms of explainability. And one of the technologies that we do highlight is explainable reasoning AI. Can you talk a little bit about how that is going beyond just what we mean by traditional explainability, and how embedding it in a model structure could maybe change governance or adoption patterns?
Sure. Interesting question again. So, what we see is when we talk about transparency and trustworthiness, explainable reasoning AI is going to be the next step, which is going to create a lot of transformation in the AI field. What we see is traditional explainable AI actually tells you after a fact why a model has made a decision. And this may be useful for audits, but it does not actually change how the AI actually thinks. So, explainable reasoning AI comes into picture and takes you further by building a reasoning model, sort of a model directly into the AI platform itself. And this basically explains the thought process in terms of making a decision. So when one needs actually what thoughts or what process has gone behind the decision making, that's where we can see explainable reasoning AI playing a very important role. And I can give you an analogy here. Let's take a very simple example of a regular AI behaving like a student who can give you the right answer, but it cannot actually show the steps involved in it. But an explainable reasoning AI will function like a student who can solve the problem on the board step by step, step by step. So you can see the difference here. And this is going to actually make the systems more trust, and it will be very useful in the high trust industries that we are talking about. How do we achieve this? It can be done by using two levels of intelligence. One is the neural networks that recognizes patterns, and the symbolic logic that actually follows the rules and leads to cause and effect. And combining these two, it can create a system that can find answers and explain them very clearly. We have classical examples of IBM Neurosymbolic AI, where it allows models to represent both conclusions and the logical pathways leading to them. Yet another example is the DARPA's Explainable AI program and Google DeepMind's Gemini models, which are like adding embedded reasoning, enabling AI to explain how a solution has been achieved and also the conclusions that have been made. So lot of this is like a step by step process in terms of reasoning as to how a conclusion has been made. And what is the case with enterprises? It causes really the game. It brings in the game change where we see governance and adoption playing a very important role. When reason is actually built into the model, what we see is things like compliance checks or audits or transparency are no longer like extra steps. They become actually part and parcel of it. So, which also leads to less manual validation, faster regulatory approvals, and this can be very useful for industries like medical and so on. And a lot of confidence that can be generated in terms of why we achieve that output. So, in industries like finance and public services, this kind of transparency is going to be very important. It's not like it's nice to have; it is going to be a must. And there is also push from global regulations such as the EU AI Act, which is going to drive how these decisions are made. What is the logic behind it? So, all these initiatives are actually going to push the adoption of these technologies. So, what it actually gives to an organization is the trust and also the afterthought. So, instead of having to explain or define the AI later, companies can actually show the proof of accountability as the system operates. So, let's take in very simple term. It turns AI into a very powerful tool, into more responsible, trustworthy decision partner. The way one can think very clearly and have a very good explanation of what the decision has been made.
Okay. So another technology that I found quite interesting, and maybe you can talk to me a little bit about this, is what we're calling hybrid AI workflows. And in our research, we note that they combine symbolic reasoning, machine learning, generative AI. Tell me a little bit more about why this convergence is really critical for enterprises to understand.
Sure. So let's take when we are combining different sort of artificial intelligent platforms together, like machine learning, symbolic reasoning, and generative AI, which leads to one powerful system. Then that becomes an hybrid AI workflow. So instead of just relying in one kind of intelligence, we are just using multiple models to get a more powerful reasoning and more powerful conclusions to the system that is being built. So what it does is machine learning and generative AI are very good at spotting patterns and creating things like text, images, and predictions. But sometimes it actually struggles to explain how they reached a decision or to follow strict rules. So what we see is symbolic reasoning is just the opposite. It's all about logic and structure, following very clear steps and rules, but it can't easily learn from large, messy data. So that's where we have all these systems combined, and we're talking about a hybrid workflow. Imagine we are having a creative student, which is like a machine learning, who can come up with clever ideas, but sometimes they forget to show their work. While symbolic reasoning is the rule following the student who never breaks that process, but it lacks imagination. When we combine them, then we have a perfect team. One can think, actually, one of the students can think creatively, the other one can reason logically. So, this is where we are having the hybrid AI workflow come into picture. And we're also seeing some examples of companies who are already playing part of this, like IBM with Watson X and UMNAI have come up with a hybrid intelligence platform, which are actually building systems that blend learning and logic. And often this is called as the neuro-symbolic AI. Most of us know about it. And what we see is these platforms are already being used in industries like energy, utilities, and logistics, and that are very useful for making complex decision making. What is actually making them very powerful is that every AI decision that can be traced is going to go through a proper chain of reasoning. So we see that once a conclusion has been made, it's like unlike the traditional AI models, which actually cannot show the reason, but how a conclusion has reached. So this is where we see hybrid AI workflow playing a very important role. And what we also see is collaboration as the biggest advantage, where hybrid AI makes it possible for humans and machines to work together in a more natural way. So, when we take industrial automation applications, this is going to play a very important role because it can explain the logic and people can correct it, question it, and also confirm its reasoning. So, this actually turns governance from separate and after the fact process into something which is actually happening right now. So, in very simple terms, what I can say is hybrid AI represents the next stage of intelligent systems, a system that can learn, reason, and justify the decision. And for enterprises, this is going to be really innovative, but it is also going to be more dependable, and more compliant. So it's just not about automating decisions anymore. It's about enabling the users to understand and defend those decisions. So that's where I think the hybrid AI will play a very, very important role.
So, how are all three of these technologies coming together to really address that trust gap that we have with AI?
Okay, so I want to give an interesting example for the trust gap that you mentioned. So let's take a team where we have to build a trust. Everyone on the team has to play a very important role, right? So it's not about one person with one sort of knowledge. Only when everyone is working together, things are going to run smoothly. So it's the same that I think with all the three technologies, the vertical LLMs, explainable reasoning AI, and hybrid AI workflows. Each one has its own strength, which adds to the trust aspect of the team. For example, we can think about vertical LLMs as models or specialists on the teams. They really understand their domain, whether it's healthcare, finance, or law that we're talking about, because they are trained on industry data and regulations, and they can make very less mistakes. And it actually gives you answers that fits the rules of the field. So this is where vertical LLMs will play a very important role in terms of being a team member. And then we can think about explainable reasoning AI as a teammate who always shows its work. So it doesn't just give you an answer, but it always walks you through where you have got the answer from. So this is actually useful for users, regulators, and business leaders, where trust is going to play a very important role, where they have to actually come up with a logic. And then we have the hybrid AI workflows, who's actually like a team coordinator. They bring in the creativity of machine learning together, along with the structure of logical reasoning. So all of these together is what we see as the as as a fact of making closing the trust gap that we're talking about. So AI just stops from being a black box and it acts as like a trusted partner, very smart, transparent, and accountable system. So this is how I see all three of them blending together to bridge the trust gap.
And which of these do you think is going to scale first, and which do you think maybe might need a little bit more ecosystem maturation?
Okay, so I'm going to think each of these like runners in a marathon. Some of them are sprinting ahead while others are pacing themselves for the long game. For example, we have vertical LLMs, which are like front runners, and they have got an head start because the track is already built there for them. And this we have seen in industries like finance, healthcare, and law. which have actually have had strong data pipelines, more clearer regulations, and tech vendors are ready to go for it. So these models are like a right fit because they're compliance ready and they can start delivering immediate value. So they will be the front runners. The next I see is explainable reasoning AI, which is fast but little behind them. And I can imagine that as a runner who starts a little later, but it can quickly gain speed. How? Like we have regulations like the EU AI Act, which is giving an extra push. And we also see companies requiring more to use transparent and affordable AI systems. And that's where I think the adoption is going to pick up fast. The next will be the hybrid AI workflow, which is like a marathoner pacing for the long haul. They need more preparation, and I also feel that they need better coordination between learning models and logical reasoning systems. And they also require consistent governance rules and more strong collaboration amongst the vendors. This is actually going to take a lot of time, but it is moving very smoothly, is my observation. So what we see is, in order to keep this moving, I can say that vertical LLMs is going to lead, followed by explainable reasoning AI, and hybrid AI is running, but it's in the long distance course. And this is how when the enterprises start using them, I think it's all going to fall in place in terms of how responsibly and sustainably they are going to use this in the future. So this is my observation, Jinian.
Great. Thank you so much, Kasturi. That was really useful. Himanshu, I want to bring you back into this conversation and talk a little bit about one other theme that I think we've touched upon in our conversation today, but that maybe we can press on a little bit more, which is intelligence that really learns and evolves and self-evolves, if you will. So one of the technologies that we hone in on in our top 10 is self-improving AI, which, of course, sounds a little bit futuristic. Maybe let us know a little bit about what is the reality of this technology today, and how close are we realistically to seeing self-evolving systems?
Yes, self-improving AI does sound futuristic, but it's already starting to take shape in controlled and early experiments. So right now, most AI models can only do what they were trained for. They stay static until uh, engineers step in to retrain them. But self-improving AI changes that completely. So these systems, they can analyze their own performance, they can learn from feedback, they can make small adjustments automatically to get better over time. So the real breakthrough here comes from what is called meta learning, basically AI that learns how to learn. I know that sounds a little complex, but a great example is from Japan's Sakana AI, which developed the Darwin Gordon machine. So using this self-improving AI, it doubled its performance after 80 learning cycles, and it did that without any new human coded updates. So I think this is a great improvement to what was traditionally going in the past. Again, over at MIT, researchers built the SEAL framework, which lets large model reorganize their own memory and logic to solve problems more efficiently after each of the recursive attempts. So this idea of AI refining itself isn't just in theory anymore; it's already being tested in labs. And when it comes to enterprises, I know this technology will take a little time to implement itself, but when it is implemented with the enterprises, I think the near-term impact is in what we call the safe self-optimization. These systems won't rewrite themselves freely, but they can fine-tune parameters, improve predictions, or adapt to new data, all under the human supervision. So imagine a fraud detection or supply chain models that automatically adopts as the conditions change. Of course, safety and governance will remain critical over here also. Because a self-updating model needs a strict oversight with safety layers that record every change and require human approval for major updates. So we are not at the stage where AI evolves on its own, but we are seeing the rise of systems that can learn continuously under guidance. So it's a realistic and safe step towards AI that keeps improving just like we do.
I want to jump to a technology that I find really fascinating, which is swarm intelligence and what we mean by that. We posit swarm intelligence is that shift from single model to collective cognition.
Mhm.
Can you explain that a little bit? And then where do you see that practical traction for a technology like this?
Okay. So swarm intelligence takes its inspiration from nature. Like we see birds and various animals. So instead of relying on one giant model to make all the decisions, many small agents they work together, each following a simple rules. And when they collaborate, they form a system that is far more adaptive, scalable, and resilient than any single model on its own. We are already seeing some exciting real world progresses. Uh, for example, in defense, the Swedish armed forces they collaborated with Saab recently and demonstrated a drone swarm wherein one operator could sorry control around 100 drones at once for surveillance and tactical missions. I think that is a great use case. uh, we can also find some uses in logistics when companies are experimenting with fleets of delivery robots that talk to each other or to avoid congestion and find the most efficient routes. So these are some of the use cases which are evolving in the swarm intelligence technology area. What makes swarm systems so powerful is that they are decentralized. There is no single point of failure in this. Uh, Even if one agent fails, the others automatically adapt and continue the mission. So that makes them perfect for critical environments like disaster response or warehouse automation, or even in applications in defense, wherein safety is very much critical. Right now, most of these are still in pilot stages, but the early results are quite promising uh, because as connectivity, edge computing, multi-agent coordination, these technologies they mature. I think swarm intelligence will shift from being an experimental idea to a practical part of every most of the enterprise operations, changing how intelligent systems cooperate and not just compute.
Thank you so much. And I'm just kind of cognizant of time. There are a couple of other technologies in that top 10 list. But just to kind of make sure that we have a little bit of space here at the back end. Isaac, I'm going to pull you back in and I'm going to put you on the spot a little bit. I'm curious, looking across the top 10 that we profiled, which single technology do you think is going to be most transformative by 2030? And why do you think that is?
Yeah, I mean, that's going to be a really difficult pick. But, going back to one of the questions that you had, right? The trust gap and why model performance is on one side progressing, but as much as model performance is important, there are needs that probably are nice to have versus must have. And if you look at what are the must haves while deploying AI, in our view, explainable reasoning is probably the most transformative, right? So we want to move the AI from being a black box to a glass box. We want to have transparent decisions and reasoning behind each of those decisions. And before we hand over actions for critical assets to the AI model, we want to be able to allow AI to discuss and reason with humans on why the choices and actions were proposed before the actions are taken. So there are ways in which we can think about it, but I believe in our view, explainable reasoning is probably one of the most critical and transformative by 2030. And we're seeing some indications where companies are beginning to introduce explainability in their own interfaces and explainability, not just conversations, but bringing in more context into the reasoning as well. So that I think is probably one of the most transformational, especially driving adoption in sort of the critical sectors like healthcare, BFS, handling those sensitive data sets, and public sector and critical infrastructure where you have billions of dollars tied to capital assets. So yeah, I believe this is where we need to be really paying attention to. Yeah.
And what do you think is the biggest misconception that you hear from enterprises about preparing for this next wave of AI?
Yeah, I mean, AGI is written off as a conspiracy. I mean, we really don't know what AGI really means, the hypothetical level 4. And the reasons behind it are kind of real. We have all the hallmarks of conspiracy theory behind AGI. But the misconception, I believe, is thinking of AGI as something sudden and that will some sort of a singularity moment that will largely impact all industries. And this singularity narrative often ties AGI to the development of consciousness and self-awareness and the desire to take over humans, right? So that's probably the misconception and the conspiracy behind why AGI is probably getting written off. But how we look at this is, this sort of delays enterprise action on critical AI technologies that we see value recognition being possible in the mid to long term, right? So we see that the conspiracy has confused capability with consciousness, and this has led to enterprises viewing AGI as a distant sudden event, right? Delaying businesses to act on measures that they can prepare for in terms of immediate disruptive impacts. And I think that's probably just our view on why AGI is sort of a conspiracy as of now.
So then what are organizations to do? Like, how do they balance ROI, short-term ROI, which is, the big thing, right? How do we make the AI that we've invested so much in actually profitable for us? But yet still having to build this readiness for these futuristic capabilities that are right down the road. What do they do? What do you recommend?
Yeah, clearly, we just need to look at the technology landscape and understand which technology is at its maturity scale and prioritize those technologies, right? So that it's easier to identify the technologies that are moving from concepts to production. For example, vertical LLMs, explainable reasoning AI, cognitive digital twins, AI augmented edge computing, multisensory world models. These are all technologies that we see real world examples and cases that are being built around these technologies. And we were just at the GDC in Washington. We've also been at other events. We see many of the startups showing some real credible, use cases for some of these technologies in more regulated and guarded industries. So which means that the models are getting refined and fine-tuned in applications that are really critical, and the guardrails are going to be designed for those mission critical applications, which means that the model has really the right level of refinement. And in the medium term, 24 to 16 months, enterprises should prioritize incubating hybrid AI workloads, lifelong learning, swarm intelligence, and self-improving AI in sandboxes, right? So that they're able to find paths to new capabilities as they transition from level 2 to level 3. And in the long term, I mean, it's all about what comes along the way, and it allows enterprises to have a sort of a dual track, thinking in short term versus the medium term, and have the preparedness required as the new technologies arrive. As a rule of thumb, we are talking to enterprise customers and tech vendors as well. We see the mix somewhere in 60 to 70% range for investments going towards the value now programs and the payback in a year, and 20 to 30% in sandboxes for testing and incubating. And that's where I believe most of the investments are going to be in. Yeah.
Great, thank you. So thank you, everybody. Himanshu, Isaac, Kasturi. It was a really helpful and insightful discussion. I think what we've learned today, of course, is that the next frontier of AI is not really going to be defined by one breakthrough, but it's going to have to be many technologies working together. Hopefully, you guys in the audience took away some of those technologies that we're really keeping an eye on that are, right just there within the horizon. To our audience, we do invite you to access a complimentary download our article on demystifying AGI, the path to thinking machines, written by our managing partner, Richard Sear, to learn a little bit more about our research and technologies in AI. For some deeper insights here, you can do so by just scanning that QR code that you see on your screen. And then we also invite you to tune in to upcoming sessions on technological innovations that are shaping the future of business. So until then, thank you so much and have a great day.
Thank you.